show where we delve deep into the incredible world of engineering and we discover how engineering has been shaping our everyday life. I am your host Andrew Adebalo, and I'll be deputizing for your regular host Tunde Odlaniran is not on this program today. And remember, this show is brought to you courtesy Prince Engineer Yemisi Shillion, FNSE. But before we proceed into the matters of the day, we'd like to take the question of the day. And the question of the day is, which of the following is the largest planet in our solar system? We have A, the Earth, B, Saturn, C, Jupiter, D, Uranus. You can send your answers to any of our social media handles, or you can call the studio line directly. Remember, this program is a two-way communication. You calling into the studio or interacting with us on any of our social media handles. And before we get the program started properly, we take this quick break, and when I'm back, I will unveil the brilliant mind that is with me in the studio today. And we are back and straight into the matters of the day. Remember, this program Engineering and You is brought to you courtesy Prince Engineer Yemisi Shillion, FNSE. He is the sponsor of the program. And I have with me in the studio today Professor Akinlami Johnson Oluwafemi. He is a professor of condensed matter physics, Federal University of Agriculture, Abeokuta, here in Ogun State. You're welcome to the program, sir.
Thank you, sir.
And today he would be, sharing his thoughts and he would be educating us on the principles of physics in our everyday life. Remember, you can be part of this program by calling in or simply interacting with us on any of our social media handle. Professor Akinlami, we are talking about principles of physics in our everyday life. How does physics affect or apply to our everyday activity?
Thank you very much, Mr. Presenter. Every part of our life we see physics there. Physics is the study of natural phenomena. And then these phenomena are motion of the body, heat, radioactivities, wave, and some other phenomena. Now, it's a study of the nature, and we use some parameters to study the nature or the phenomena that was observed. We call them observables. Okay, we call them observables. For example, motion of the body. If the body moves from one place to the other, we talk about the speed or the average speed. We talk about the distance it covered, and we also talk about the time it takes. Now, those are the observables. And whatever we observe as physicists, we describe them with a model, a mathematical model, and that's equation. And then we see all this, all of us, we move, human beings, we move from one place to the other every day, at home, to go to work. That is physics. work. And so today I will just mention some of the principles of physics that is being played out in our day-to-day activities. But before then, let me just mention some areas of specialization of physics. One is condensed matter physics. These simply deal with study of materials at their solid state, liquid and gaseous states, the properties of material, like thermal properties, like optical properties, like electronic properties, their thermodynamic properties, to see what they can be used for. So when we know the property, we know which material is fit for this or that, especially in our electronics industry. I'll talk about semiconductor devices. So when we study this material, then we recommend that this material is good for this, is good for that. In fact, we have some type of material now, we call them thermoelectric materials. And those materials, their job is just to convert it, waste it, to electricity. I know that in the world today, energy is a problem. And so that's part of the work of a condensed matter physicist. A theoretical physicist deals with the theories of physics, or the theories, the formalisms. That's what a theoretical physicist deal with. Then we also have solid earth and geophysics as an area of specialization in physics. And these are the people that study the earth core. So what's beneath the earth? The thermal properties, then the prospect for water, the prospect for minerals. So that's one area. Another area is radiation and earth physics. And this one, we see it every day. If you go to the hospital, they apply radiation to treat cancer. We have another one, atmospheric and ionospheric physics. This one, they deal with studying of the atmosphere, the electrical discharges there, the weather conditions, and they can make predictions. So they can make predictions. Then we have also instrumentation and electronics. These ones, they are the one that fabricates, they design equipment. We have another one, environmental physics, that has to do majorly with solar energy. Now let's take a look at some of these principles as we see play out in our day-to-day activities. The first one, Newton's first law of motion, simply say that everybody who continues in a state of rest or of uniform motion unless acted upon by a force. Now, implication of that first law of motion, we see play in our life, daily life. If you bought a taxi or you drive your own car and you have passengers with you inside the car, and maybe you sighted a pothole and you try to apply the brake, everybody, all the occupants of the vehicle, they will jack forward. Mm-hmm. That is the implication of the Newton's first law of motion, that a body in uniform motion will tend to continue like that except a force brought it to. So that's why all the occupants are in motion and they tend to continue until the driver applied brake and they were stopped suddenly. That is physics principle at work. Then the second law says that force is responding for motion of anybody, and simply that the rate of change of momentum with time is directly proportional to the cause that produced that force. And what is that cause? Is force. So that means force is responsible for motion of the body. Force is responsible for deforming some bodies. Force is needed to expand strings. Force is needed to bend irons. So, in fact, we apply force every day. For example, we want to fetch water, for example.
You apply force.
We apply force. If you don't have a borehole at home, even with borehole, that's a machine. Doing the work that we're supposed to do for us. So, but you don't have a borehole, but you have a well. Now you now put a wheel and axle. I'll soon get there. Then you tie your drawer with rope. Tie around the wheel and axle. So it has an handle which you are going to draw like that. So as you roll it, you fetch water, you roll it down, it goes down. Now your drawer is load. And you need force
to pull it,
effort to pull it up. So by the time you apply that effort, then you have applied force. Before you know it, the drawer is up. You pick it, you fetch your water. So in every day, we apply force.
from turning the doorknob.
Yes, that's what we call it, a contact force. Because you want to open the door now, you have to
Turn
either a push
or a
or a pull. Pull is you pull it to yourself. That's application of force. Then push, you push it. At your entrance, when I was coming in, the type of door you have there operates on the principle of physics, PSO electric effect. It senses the presence of some human being. It opens on its own. You pass, it closes back. That's physics at work. Then we have action at a distance, force. Action at a distance, force. This one, you don't have, the force doesn't have to be in contact with the objects. But you feel the effect at a distance from that. For example, we have what you call force field, like electric field. If a charge comes into that electric field, it's going to feel the presence of the electrical force. And so, then the effect of the force will be produced because the presence of the electric field. That one now, you don't need to touch.
The force field is at work.
Is at work. And we see, just like your door now, we didn't touch it. It says the presence, action at a point, at a distance. So then we have the third law, which says that action and reaction are equal and opposite. That is, if you apply a body, let's say a body here now, apply a force on body B. Body B, body A itself that apply the force, we also feel the effect
of the force
applied on B,
such as
which will now be a reaction from B to A.
Such as when you hit a stick on a wall.
Yes.
You feel the impact.
The impact is the reaction. So it will be equal but opposite in direction. And like for example, some people that like to kill students very well before it was prohibited or prescribed. Anytime you raise a stick, both the student or the child and the person beating him or her are sharing. You give one pan, you get a reaction back. You give another one, you get a reaction back. So if the car, two cars, they collide, there's also that there. So that's for the Newton's law. But Newton's law has made life so easy that we want to do work, we need to apply force. Like all of us, whether we like it or not, as human beings, we have to work on this planet Earth before we eat. Apart from working, some of the things we do at home, we need force. And we need some machines, which are also an application of forces now, that will help us to do those work with ease. Like I mentioned, drawing water from the well. There are machines to do that for us now. Whether submersive pumping machine or surface. They are all working on the principles of physics. But we have some simple ones that we can see all around us. For example, we we have what is called inclined plane. If you look at the figure there, the diagram there, that was one in red, and a node yellow on top of it. Now the inclined plane, if you go to Kucha market, I've seen it a couple of times when I pass through the place. They want to offload drums of oil, palm oil. They need several men
to help them
to carry it and offload it. But now, with the inclined plane, you just need a plank. A plank inclined at an angle to the door, the lorry floor. Then the other one on the ground floor. All you need to do, little effort to be used now, because that is the essence of simple machine. It makes life very easy for you. Just a little roll. The drum of oil will just roll down, you find it on the floor. The next one on the floor. The next one on the floor. As many as want to offload. So that is physics
at work.
But people say it, they don't take cognizance of that. Then we have, I've mentioned wind and lasso, want to fetch water. It's a simple machine. Then we have pulley systems. If we go to our wharf, our Papa wharf, our ports, you see the way they upload everything. It was on the principle of pulley system. So just the machine will do the work. Just give the machine work to do. So machine really makes life very easy for us. Like for example, I've mentioned moving from one point to the other. In the olden days, our great-great-grandfather, they work with their legs when there are no automobiles. But thank God for science, thank God for research, thank God for discovery. They started with bicycle. No, before bicycle we have donkey, horses, chariots. Because they need to move. And we know that's one of the characteristics of living things. We have to move
from one point to
the other, whether we like it or not. We cannot just be stagnated in one place. And so there comes about discovery, and they get a car. Even that car, when you apply your torture, you are applying a force to put that car in motion. When you want to stop, you apply another one through the brake to come to rest for you. So it makes life a lot easier. But these are the principles of physics at work. Now, we have another one. One of the principles of physics is heat. Phenomenon of heat. Then we need heat energy. Okay? But we need also to measure temperature of a body, even ourselves, so that we know that we're healthy. There's a required temperature for a normal human body. The clinical thermometer they use in the hospital works on the principles of physics. The liquid, the mercury inside that clinical thermometer, once it senses temperature, it rises up. That is under heat. Okay? Then we know that heat flow from higher temperature to lower temperature. So if two bodies come in contact, one at higher temperature and one at lower temperature, the one at lower temperature will take part of the heat energy from body A, and both of them will now come to equilibrium. That's what we call heat transfer. And heat transfer takes place through three modes: the radiation, conduction, and convection. Now, the sun rays, the cosmic rays that come from the sun, get to Earth through radiation. We all feel it every day.
Professor, before you proceed, you can be part of this program by calling the number on your TV screen. You know, this program is a two-way communication, and it's also geared towards encouraging the younger generation to pick up interest in science. And today we've been talking about how physics have been affecting our everyday life, and we are in the studio with Professor Akinlami Johnson, and he's been sharing his thoughts and educating us on the subject of today. And so you can be part of this program. Call us, and remember, we have a question, and when you answer our questions correctly, there is a prize for you, courtesy the sponsor of the program, Prince Engineer Yemisi Shidon, FNSA. So Professor, please go on, sir.
So we also have, apart from types of thermometer we also have the useful effect of radiation in our day-to-day activities. We know that in treating tumors, cancers, radiation is being used, and all the machines that are being used work on the principles of physics. Now let's come to the electricity that we have. The electricity that we have, this place is well illuminated now. The discovery was due to an experiment by a physicist, Benjamin Franklin, in the 17th century. He started the discovery. And what did he do? Simple experiment. There was thunderstorm. It's raining and there was thunderstorm. And he fly a kite. And there were electrical discharge.
So we have John calling from Ikorodu. John, good evening.
Good evening, sir.
So do you want to answer our question, or you want to ask the professor a question?
I want to answer the question, sir.
Okay.
The answer is Jupiter.
The answer is
Jupiter.
okay. I'm going down to the end of the program, John. I will tell you if you are correct or not. Thank you for calling, John.
So Thomas Edison, Michael Faraday, they all work on electricity. So today now we need energy to power our TV, our radio, our computer. All these are principles of physics at work. So okay, want to ask a question?
Time is no longer our friend, and how can we harness these properties and power of physics to good use?
Well, we need to train more physicists. We need to provide equipment for them to work. So, because when we train more people, at least there'll be more enlightenment. Encourage more younger people to study science.
So please, before we go, Taiwo calling from Abeokuta. Good evening, Taiwo.
Good evening, sir.
Good evening. Do you want to ask the professor a question, or you want to answer our question of the day?
I want to answer the question, sir.
Okay. Go ahead, please. Hello, Taiwo.
Hello, A is the answer, sir.
You said A is the answer.
Yes, sir.
Okay, we'll let you know if you're correct or not before we end today's program.
Okay.
Thank you for calling. So, Professor, your parting shot, your final words on the program before we let you go today.
Thank you very much, sir. I'll just say that as a nation, we should embrace science, technology, engineering, and mathematics. Encourage young people to be there so that we can move our country forward. We can revolutionize our country. Because the role of physicists and scientists is very, very important in any society that want to develop.
Thank you so much, Professor, for that. And our question of the day was, which of the following is the largest planet in our solar system? We asked, is it Earth, Saturn, Jupiter, or Uranus? And the answer is Jupiter. But before we go, we have the question of the week. And our question of the week is, An engineer who designs and develops systems for transportation of people and goods is called what? A, aerospace engineer, biomedical engineer, civil engineer, or environmental engineer. Kindly send your answers to the following social media handles you're seeing on your TV screen. So thank you, Professor Akinlami Johnson Oluwafemi, for being on the program today. It's quite entertaining and lively with you in the studio. And remember, Engineering and You is brought to you courtesy Prince Engineer UNC Shillong FNSC. Join us again next week for another interesting episode of Engineering and You. My name is Andrew Adebayo. Till we come again next time. Please, in everything you do, try to get knowledge and understanding. See you again next time.